Hi everyone, I'm Choi from KAIST. Today I'm presenting our paper, Vivid Human AI Collaborative Authoring of Vicarious Dialogues from Lecture Videos. This work is done by me, Hyewon, Yoonjoo, and Juho. Online lectures are widely used for conveying knowledge in various learning contexts. They usually take the form of a lengthy monologue, so this format can cause learners to feel disengaged or lose interest easily. To improve a learning experience and learning effect, research has shown that the importance of incorporating conversational agents into video learning environments. However, they have supported mostly the learners known as direct learner who prefer to interact directly with an instructor or peer learners. According to vicarious learning theory, there are not only direct learners, but also vicarious learners who prefer to learn from interactions between other learners and an instructor. And these vicarious learners can benefit when observing a tutoring between an instructor and direct learners. Thus, several studies explored adding observable dialogue to video lectures. These approaches show promise in improving the limitations of traditional online lecture format and satisfying the needs of vicarious learners. However, to reduce the cognitive load caused by lectures, which is a fundamental factor impairing online learners' participation and interest, it is important to expand existing lecture content in a more understandable dialogic format. However, there is no research on new guidelines for designing pedagogically meaningful dialogue that is beneficial to vicarious learners. To make this guideline, we organized a design workshop. Before the workshop, we established criteria for effective educational dialogue through iterative inductive literature analysis. And then we conducted a design workshop with 7 teachers and 8 educational experts. During the workshop, participants set problem scenarios in groups, designed a dialogue from a lecture without LLM, and designed a dialogue using LLM. Through our workshop, we derived 5 design recommendations necessary for designing pedagogically meaningful dialogue. First, dynamic. The dialogue should include various interaction patterns to reflect the conversation dynamic that often occurs in real classrooms. Second, academically productive. The tutor in the dialogue should encourage metacognitive and constructive utterances of direct learner to make a dialogue academically productive. Third, cognitively adaptive. The tutor in the dialogue should adapt the teaching strategies to the level of the vicarious learner, learning objective, and lecture contents. Fourth, purposeful. The learning objective of dialogue should be defined for the vicarious learner, and that objective should be achieved through dialogue. Lastly, immersive. The dialogue should be based on realistic teaching scenarios and matching the direct learner's cognitive level with the vicarious learner's level. We also observed how LLM can be utilized in designing dialogues. Participants found it challenging to design the overall structure of dialogue from the scratch and come up with appropriate utterances considering the level of direct learners when creating dialogues without LLM. However, we observed that LLM can offer valuable guidelines for structuring dialogue and provide diverse learner responses or sub-dialogues at different levels of detail. Based on observations, we devised 4 design guidelines for designing Vivid. First, the system should enable instructors to easily simulate direct learners easily. Second, the system should assist instructors in designing dialogues by referencing utterances generated at various levels of granularity. Third, the system should assist instructors in creating dialogues that reflect the user's dialogue usage context and personal experience with students. Fourth, the system should ensure that instructors consistently monitor important considerations when designing vicarious dialogues. Based on our 4 design goals and the observed dialogue design process during the workshop, we propose a collaborative authoring process consisting of 3 stages. We design Vivid based on this. When uploading lecture videos to Vivid, it undergoes an initial generation stage, comparison and selection stage, and refinement stage to transform specific segments into educational dialogue. Firstly, Vivid initially creates various dialogues for instructors to choose the one that best aligns with their intention for converting monologue to dialogue. After instructor upload their video, they can select where to convert into dialogue and highlight the part where the Vicarious learner might have difficulty. After inputting a specific learning context and scenario, they can see several dialogues. During this stage, the LLM-generated dialogue advances through 4 phases to ensure that these dialogues are built upon a finely constructed knowledge set of the direct learner. This process aims to meet 3 design recommendations for Vicarious dialogue, which are being dynamic, academically productive, and immersive. To make this quality dialogue, Vivid creates an understanding rubric for highlighted areas first, and then determine the direct learner's understanding level for each concept in selected lecture part. Create direct learner's possible questions and answer sheet, and generate dialogue using all the information regarding direct learner's knowledge state into prompt. Instructors then compare and select the generated dialogues. Each dialogue is shown in card format. When the instructors choose a card, they can see the knowledge level of direct learner, key learning strategies, and utterance patterns. Lastly, instructors can refine the selected dialogue by collaborating with LLM. Instructors can refine their dialogue manually, such as adding or deleting utterance. Furthermore, Vivid offers a laboratory which enables instructors to refine dialogues by exploring various versions of selected subdialogues. We conducted 2 fourth evaluation studies, which are technical evaluation and user study. For the technical evaluation, we evaluated whether our initial generation prompting pipeline can generate dynamic, academically productive, and immersive dialogues, and whether our end-to-end authoring pipeline can support instructors to design dynamic, academically productive, immersive, and correct dialogues. In a nutshell, our technical evaluation proved that the dialogues designed with Vivid were more dynamic, academically productive, and immersive than baseline. In terms of correctness, instructors' refining process produced highly correct dialogues in both conditions. We also conducted a within-subjects experiments with 12 secondary school teachers. We asked participants to transform a part of lecture video chosen by the authors into a dialogue under each condition. We summarized 3 main findings from the user study. First, Vivid helped participants monitor essential considerations when designing conversations. This is the result of users' perceived utility survey. And there was a significant differences between conditions in Q9, which is asking how useful was this system in continuously monitoring the essential consideration when designing dialogues. Second, Vivid helped instructors simulate a direct learner with diverse levels of understandings. The difference in results of Q2 was not significant, but some participants highlighted that Vivid was better at selecting a suitable dialogue by considering the direct learner's knowledge level for each dialogue than baseline. Third, as participants mentioned like below, Vivid's laboratory feature helped instructors better predict the direct learner's responses and improve the dialogue's pedagogical quality. According to our findings, pedagogical quality of the dialogues authored by instructors was significantly high, while the perceived usefulness of Vivid was not significant. We believe this gap occurred for 2 reasons. Firstly, low explainability and informativeness of dialogue design described in the highlighting feature and dialogue cards. Some participants mentioned that if they had a better understanding of how each feature influenced the dialogue generation, they would have used the system more effectively and experienced better satisfaction. Additionally, we observed a disparity in identifying the differences between the understanding levels of direct learners and teaching strategies in the given dialogues among instructors with different levels of experience. We also believe that the perceived utility was low due to the low controllability of our laboratory feature. We observed instructors showed variable expectations for the modified versions provided by the laboratory feature. Thus, we suggest enhancing explainability of each feature in Vivid and providing fine-grained controllability to instructors. Vivid can utilize beyond video lecture context, such as in diverse learning contexts, learning materials, and learning stage. With Vivid, instructors can generate scalable, meaningful pedagogical dialogues. However, the challenge lies in determining how these dialogues can be effectively delivered to real learners. How can these dialogues be seamlessly incorporated into the video learning environment to enrich learners' experiences and optimize learning outcomes? We suggest to personalize the Vicarious dialogues by utilizing each Vicarious learner's data. Furthermore, we believe that Vivid can be expanded to personalize the interaction between learner and agents. Thank you.